Today, we are going to be entering the equations of motion, physics, equations of motion, and we are going to learn how to apply the equations of motion. So just listen to me on this aspect. Under the equations of motion, we have so many equations, so many of them. We have the first one, or one of them, which says that V is equal to U plus AT. V equal to U plus AT. We have another one which says that V square equal to U square plus 2AS. We also have another one which says that S is equal to UT plus half AT square. Another equation. Then we have another equation which says that S is equal to U plus V over 2 times T. V equal to U plus AT. V square equal to U square plus 2AS. S is equal to UT plus half AT square. Then we have S is equal to U plus V over 2 times T. These equations are very valuable to you. Take note of them. Now, some of you may be asking, what does V mean? What does U mean? What does A mean? What does T mean? All these things are questions. What does S mean? So I'm going to say that S is distance. S is distance. A is acceleration. But this A you are seeing here now can also be acceleration due to gravity. So the acceleration depends on the question. If it is falling from a height, that deals with acceleration due to gravity. But if it's acceleration, just like car movement, or deceleration, maybe you are applying a brake that deals with retardation, that is different from acceleration. You know, there's acceleration, there is retardation. That has to do with when a brake is applied to a car, a moving car. Retardation. So acceleration can be deceleration, can be retardation. Then we have S equal to distance, A equal to acceleration, T represents time. We also have V. Now V can be divided into two types. We have the initial velocity, and we have the final velocity. So we can divide V in two types. We have V, which is the final velocity, and we have U, which is the initial velocity. So we have V equal to U plus AT, V square equal to U square plus 2AS, S equal to UT plus half AT square. Then we have S equal to U plus V over 2 times T. Now, I'm going to explain how this works. I will explain to you how this works. So there are situations where a car starts from rest. That means the car was first stable, was in a resting state. That means it was not moving. Then it now started moving. That situation, it implies that the initial velocity is 0. So in a situation where a car starts from rest, it implies that the initial velocity is 0. Initial velocity, that's U, is 0. Then in a situation where a car goes to rest, it implies that the final velocity V is 0. A situation where a car starts from rest, the initial velocity is 0. And a case where a car goes to rest, the final velocity is 0. So these points are very much important as we are going to be solving questions together. Now I'm going to read out a very valuable question, and this question will be displayed on the screen for each and every one of you to watch. So the question says a very simple question at that. It says a body accelerates uniformly from rest at a rate of 3 meters per second square. 3 meters per second square for 8 seconds. Because calculate the distance covered by the body during acceleration. It says a body accelerates uniformly from rest at a rate of 3 meters per second for 8 seconds. Calculate the distance covered by the body during the acceleration. So whenever you are writing a physics exam, but now you know Waec is now going to be online, but definitely you are also going to be writing theory exams. But take note of this question again. Whenever you are solving a physics question, the first thing you are going to do is to write out your parameters. As an SS1 student or SS2 student or SS3 student, write out your parameters. What were you given? The first thing, a body accelerates uniformly from rest. Like I told you, if a body starts from rest, it's accelerated from rest, it implies that the initial velocity is 0. So we already have uniformly from rest, u is 0. And you'll be wondering, what is the unit of velocity? The unit of velocity is meter per seconds. We are going to do that shortly. I will explain to you how we got meter per seconds. Then the next thing, they gave us the time. Accelerates uniformly from rest at a rate of 3 meters per second for 8 seconds. Then the time, they gave us time to be 8 seconds. Calculate the distance covered by the body during the acceleration. So they are asking us to find S. We don't know S. Now we are going to ask ourselves a very simple question. Which equation can help us to find S? Which equation can help us to find S? Now they also said at a rate of 3 meters per second square. That means they give us acceleration to be 3 meters per second square. Acceleration to be 3 meters per second square. So to solve this question, we are going to write down the 4 equations of motion again. We have V equal to U plus AT. We have S equal to UT plus half AT square. We have S equal to U plus V over 2 times T. Then we have the other one, which is V square equal to U square plus 2AS. Now asking yourself this question or examining the question on the board. We have U. They gave us U. Here there is U, there is U, there is U, there is U. But the next part says T. There is T. But did they give us V? No. That means we cannot use this first one. Now, in this one, there is T. Sure. There is S. Sure. And there is A. Sure. That means we can use equation 2. So we have S equal to UT plus half AT square. We are looking for S already, so we don't need to change our subject or formula. So we have U. U is 0 times T. What's T? 8 plus half times A, which is 3, times T, which is 8 times 8 over 1 over 1. So we are going to write 2 here, 1. 2 into 8 is 4. So 8 times 0 is 0 plus 3 times 4, 12. 12 times 8 will give us 96 meters. So S equal to 96 meters. So from this question, we'll be able to get S to be 96 meters. So S is 96 meters. Then we have another question here, which I'm also going to display on the screen as well too. The question says, the motion of an object moving in a straight line is uniformly retarded. The motion of an object moving in a straight line is uniformly retarded so that it comes to rest in 20 seconds. So let me clean this what we have on the board now so we can answer question 2. Question 2 is also very simple as well too. So we are going to analyze it together. So question 2 says the motion of an object moving in a straight line is uniformly retarded so that it comes to rest in 20 seconds after traveling a distance of 40 meters. Full stop. What is the initial velocity of the body? Now, I told you, a body starts from rest. That means initial velocity is 0. A body is going to rest. It means that final velocity is 0. A body is going to rest. That means the body was already moving. Was moving. Then what happened? Just mash the brake. That means you stop the body from moving. That means something happened. That means the final velocity is 0 because you have applied brake. 0 meter per second. Now, after applying that, we also found out that the distance they gave us the distance to be 40 meters. Then the next thing is the time was given to be 20 seconds. 20 seconds. Now we are told find the initial velocity u. We don't know u, so we are going to start again and write out the equations. V equal to u plus at, s equal to ut plus half at square, s equal to u plus v over 2 times t, and v square equal to u square plus 2as. So we are going to check. For this, we have s, we have u, we have v, and we have t. So we are going to use this equation. S equal to u plus v over 2 times t. What's s? 40 equal to u. We're going to write u like that. V is 0 over 2 times t, which is 20. So we have 40 is equal to u over 2 times 20. So 0, 0. We have 2 times 4, 8. Equal to 20, equal to 2u, meaning that u is equal to 8 over 2, which is 4 meter per second. So we've been able to get u to be 4 meter per second. U is 4 meter per second. So take note, a body starts from rest. It implies that the initial velocity is 0. A body goes to rest. It implies that the final velocity is 0. Take note of this valid point. Now, I'm also going to give you another tip in the next video. In the next video, I'm going to talk about the units of different physics quantities. Different quantities. We are going to be talking about the units. We're going to be talking about how the units came about, and also talk about talk about these units. Stay with us while we talk about this.